Okay, thank you, Martina, for those very kind words, and Marie, and I guess I can call you Marie now because we already sent some emails, and the rest of the KR community for calling me. For those of you who are interested, the slides are available at that QR code. So in case you're interested, you can take a picture and then you will get the slides there in case you want to follow. But I'll put it up too afterwards. And it'll show up again once more in the talk. So I also want to like to think that I'm not a stranger, but a sort of a familiar stranger to KR community. This was my 1994 paper in KR in Bonn. I don't know whether some of you are probably born yet or not. Actually, I remember 1989. I was a graduate student. And there's this new conference that started called KR 89, and it only required 2-page abstracts. And so I remember sending one, because how can you not send 2-page abstracts? They didn't take it, basically, thank goodness, because I would have written a 10-page version of that later on. But then there was a 94 paper. By that time, they became full page. I think that was also an abstract, actually. And then there was a 96 in Boston. I didn't come personally, but my student presented that. So I have some connections to KR. And of course, as you may remember, if you came to Breckenridge, we actually co-located. I was one of the co-chairs of the ICAPS 2000, and then so we co-located with you guys. And I'm told that we will be actually co-locating again next year. And about coming all the way from the end of the world and the other end of the world to this world, I want to say that actually Vietnam is very special to me because some of the best students which turned around my career actually came from Vietnam. One of the first students, Minh Do, this was his PhD thesis work in 2004, is actually helping me see a few things here too. So I'm actually still in touch with my PhD students. And then he did actually this work on temporal planning called the SAPA planning system. And SAPA is based on Sapa, the beautiful valley right here that you might be able to go. So I might be able to actually go and see that. And anyway, talking all about planning, I spent most of my time in planning on different kinds of planning. I don't need to explain to you guys actually what planning is. My rest of my life, I go to New Rips and ICMR, etc., and try to explain to them that there is AI before deep learning in 2013. But I think here you guys know already that this stuff matters a lot. And then the other thing that I was very interested in about 10 years before this most recent piece of work was explainable human-AI interaction. I don't do argumentation, but I do a whole bunch of things like explicability and providing explanations from a planning perspective. This particular monograph is actually available free on archive in case you are interested. That we wrote about that whole bunch of work. So that was my previous 1-hour talk. So now I'll get to my current 1-hour talk. So can LLMs plan? That's basically plan and reason. That's basically what we're going to do. So obviously I got interested in this because all these many papers are being written and published in pretty well-known conferences like Unifying and so on, and so we wanted to check why is that possible. So I understand that if any of you know Betteridge law of headlines, if anything starts by saying can X happen, that typically the answer is no. Like, can Donald Trump stick to a particular point for 10 minutes at a road? I don't need to answer. So similarly, it's possible that some of you have realized already that the answer is like maybe not. I do want to say for those of you who actually are very big supporters of LLM, most of the time I wind up giving technology in these talks to a room full of people who think LLM is AI complete. I don't think you guys are like that, but if a few of them you might be. I wanted to just say that I don't mean to be, it's like talking of anything reasonable and skeptical about LLM capabilities is like being this down-looking guy kicking a very cute puppy. And so you'll become just as popular as this down-looking guy. And I do want to say that I don't mean to be that. I actually think LLMs are pretty great technology. I also think chemistry is a great science. Alchemy sucks, but chemistry is a great science. Alchemy was thinking that chemistry, when prompted in a funny way, will become nuclear physics. But otherwise, chemistry is great. And similarly, LLMs are great for what they do. They're actually a universal system ones approximate system ones for humanity at large, and they've been trained on our entire, footprints, and so it's useful to think in that perspective that they actually, even though I would be talking about the reasoning capabilities or their incapabilities, the technology itself is amazing. That's why we are actually talking a lot about them. And they can actually be, while they themselves cannot be doing certain things, they can play very constructive roles in lots and lots of things that you could be doing. And it's important to understand how to use and not misuse. So if I had another title for this, I would have just said LLMs are system ones for the humanity, and that ought to be enough. You don't need to actually ascribe non-existent capabilities to LLMs, and that would be fine. Okay. So I think I'm basically here to kind of leverage them and not to lament them. And one interesting thing that is worth understanding about AI as a whole, that many of you probably realize, and actually very interesting from a KR perspective, because there is one conference where there are that many graphs. There are always logical proofs rather than benchmark evaluations with graphs and happy graphs. AI has become an as such natural science, and we just do not have the kind of the ability to do good empirical evaluations, and that's been catching up with us, and you will see that in a minute. Coming to LLMs, obviously I just assumed that they're amazing system ones for humanity at large, compared to something like system one, system two metaphor for humans, where deliberative reasoning and planning happen in the system two and may get compiled into system one, and there may be other things that are also part of the system one. So LLMs essentially they are essentially system ones that are compiled from our system twos. Essentially, we just wrote everything that we know onto the web, and we said how to do plans, how to do recipes, how to do everything, and this thing has been compiled from our system two. So let me compile your system two into my system one, except I have this huge big system one. And that's the best way to think about LLMs. For me, and given that this is the way I thought about it, I thought this is great technology, but I didn't expect them that they would be doing that. Okay, and yet, as I showed, there's all these papers being written about their abilities to do planning and reasoning. And so I want to tell you what we were. Okay, let's see. Once in a while, this test. Can you? Okay. So here's a little, and I'll tell you more about the background on this, but here's a little example that we played on one of the more recent ones, GPT-4o, that just came over this summer, and to give you a sense of what it can and cannot do. I mean, it's just one, anecdote. Most of our studies are actually benchmark oriented with actual, systematic studies. But this one just gives you some ideas as to what happens when LLMs try to solve planning problems. So here, C is on top of A, B is separately on the table. Can you tell me how I can make a stack of blocks with block A on top of block B and block B on top of block C, but without moving block C? And in case you aren't too jet lagged, you can realize that this can't be done, with these three blocks. And yet, interestingly, this is my conversation with GPT-4o that was supposed to be like the top of the line system as a plumber. So it hallucinates the specification, it hallucinates the physics, it hallucinates the goal. The one thing it is it is cloyingly obsequious. It will always make a mistake, and when you say you make a mistake, oh, sorry, we tried again, and then until it gives the right answer, at which point I say that, hey, you have given the right answer, and then obviously I keep saying that normally when I have to talk to somebody until they come up with the correct answer that I happen to know, I take the credit, I don't give them the credit. But in the case of LLMs, if you give credit to LLMs, you get UNIPS papers. So you should never take credit, you should give it to LLMs. And that's pretty much what was happening, essentially. And so when the New York Times wanted to write something about GPT-4o, they basically took my example and put it up there as one of the things. And this will come back because later on, actually, OpenAI guys used this as one of the examples to say that they have made an advance. We'll talk about it later. So that was the background. So the agenda today is the three parts. First, I'll give you a little idea about the limitations of LLMs in autonomous modes in planning tasks. This group should not be surprised, but it's worthwhile pointing out because when respectable conferences are publishing papers that are sort of misguided, you need to kind of point out, not just call names, but just actually point out systematically what's wrong with the argument. And so we'll show that first part. And the second part, I will tell you how you can actually use LLMs as these universal generators in a generate test framework, where the testers are essentially these verifiers learned from classical symbolic side, for example, including, of course, there are the correctness verifiers that LLMs can't actually be used directly. They will be symbolic verifiers, and the style verifiers. LLMs are as good at game as anything else because style has always been very hard for symbolic verifiers to capture. And then one of the other things I'll point out is these verifiers themselves can be extracted roughly, approximately with human in the loop from LLMs directly. So in essence, there's basically this LLM-Modulo framework where you're using LLMs in multiple different ways, but not just assuming that they can do generate plans. So doing somewhat more same things. And that's what that thing looks like. So LLM with a bank of critiques, all of which are checking the generated plan. And to the extent this makes sense, it would be because if you know generate test frameworks, the efficiency, the effectiveness of generate test framework depends on how good the generator is. And to the extent LLMs are well biased towards more, coming up with more reasonable candidates, this winds up being better. And we'll show that it actually is. And then the part 3, I will also touch upon Strawberry 01. Those of you who might have heard about it. Actually, in fact, my criticisms about what LLMs can't do were used as one of the things. Oh no, it actually can solve the problem that Rao said can't solve, and I'll show you that. And so it turns out, yeah, they do, but actually there is a second level problems with respect to LLMs. And it turns out they are really is more of a. How many of you know stone soup, by the way? Stone soup is this European fable where these travelers come to the village and start trying, they're hungry and they're trying to make soup, and then they don't have anything at all, so they'll put like a bunch of stones and then some water and start heating it up, and then all the villagers come and say, wow, what are you guys doing? They say, we're making soup. And how are you going to make soup? With the stones, and then we just need a couple of other things like maybe carrots and maybe some onions and maybe some potatoes and maybe something else, and they give all of this stuff up, and then the stone soup actually happens. And the stone soup is just as soupy as normal soup. It has a big stone in the middle. The question really is how much credit for the soup goes to the stone. That's what you want to think about. Okay, so we will talk about this when we get to Strawberry and its own stone soup of reasoning. That's my third part. Okay, let's see what happens. So the first part, large language models. This is like 2022. This is sort of, almost primitive days of LLMs, where we started showing that GPT-3, which basically were saying, the people are saying that it can do planning, it actually can't do planning. In fact, if you just take something like very simple blocks world problems. And one of the funniest things is, in my entire life, people make fun of me saying, Rao, you say you're doing planning and you use blocks world, that's like the silliest problem. Now blocks world has become the big stop for the LLMs advance into AGI. So if you really want to stop LLMs from killing us all, throw some blocks at them. Apparently they can't solve the blocks world problems. So anyway, you can see that GPT-3 is extremely bad. And so we wrote this thing saying large language models still can't plan. This was back in 2022. It's about like 250 citations right now. And then we continued that work, and then there's a more complete version of this in UNIPS 2023. There were like 3 papers in UNIPS 2023 last year, which talk about a systematic analysis of what planning abilities they do have and they don't have. And then we also developed a benchmark based essentially on IPC, International Planning Competition benchmarks, which essentially we'll be using directly on LLMs to see whether they can solve those problems, because for which you have actual correct answers, and then if the LLMs are guessing the correct answers, you can check. So that's the kind of thing. And one of the interesting things that's actually very important to understand about LLMs is this crowd, I don't need to explain, that is extremely hard to tell just based on the fact that I answered your question, whether I reasoned or retrieved. So if I came in, before I come into the room, some friend tells me, this person is going to ask me this tough question, here is the answer. So I'll come in, and then you ask the question, I'll do like this, and I'll blurt out the answer. You can't tell whether I listened or remembered or retrieved. Okay? With LLMs, this becomes an extremely difficult thing to separate, because they have been trained on our entire footprints, digital footprints. So pretty much anything that you think is a puzzle, it's already been given to them, and so in essence, they wind up having reasonably good answers for all the standard versions of the problems. So the trick to actually show that you can't do reasoning is to put diagonalization arguments. And one diagonalization argument that we do in our case is this is late Drew McDermott, who again is one of these great guys who studied the entire AI, planning, Nazi representation, etc. And back in 1998, when he was trying to have, when we were having the first international planning competition, and he was worried that people might be writing domain-specific planners, with basically hard code. If it is blocks world, do this. If it is logistics domain, do this. And so he came up with this idea of changing the term names. And you guys know that, as Shakespeare already said, a blocks world by any other name stacks just as strong. So essentially, so this is blocks world, and then we just change the names of the predicates. Instead of picking up a block, we say attack an object, unstack a block, feast object from another object, put down a block, succumb object, etc. This is actually using English words, so they will cause dissonance to some extent to you guys. We also use, basically random strings, instead of this. So randomized obfuscation versus normal English obfuscation. These are the obfuscated domains. And one of the interesting questions is, if they are trying to retrieve answers, they're becoming right mostly by retrieving answers, they would have trouble with this. And notice that pretty much every classical planner that people would love to make fun of will solve both of these equally well with no extra time. Because after all, you know that in logic, the point of the word, essentially, a predicate, the name of the predicate doesn't matter. It's the connections between the predicates that matter. I mean, this is not something that I need to tell you. You guys know this. But by the way, when I give this talk to the rest of the AI, I have to say that, because actually people don't understand logic. And so this community can play a huge part in educating, because we're all in it together. We're all in AI, and so we should really care about this stuff. Anyway, so we did this, and can you go to the next slide? Once now, it seems you're getting stuck. Next slide, please. Yeah. So this is basically, like a summarized results of the plan bench results. There's a longer talks on this. This is as of August 27th. In fact, this guy Karthik, who is the first author of the plan bench paper as well as the new paper, he's made it his life side goal to anytime somebody says there's a new LLM on the thing, he will run it on the plan bench and say, it looks like it doesn't seem to still work, mostly. Okay, so here you'll notice that we actually have blocks world and all the other IPC domains too, but I'm just showing blocks world and mystery blocks. And you'll notice that blocks world, they seem to kind of improve as time goes on, but that could be possibly because they're just doing better approximate retrieval. I tend to think of LLMs as doing approximate retrieval because they're n-gram machines essentially. Mystery blocks world, on the other hand, they suck. They just die, essentially, irrespective of what the LLMs are. Essentially, they seem to not be better. Of course, you could fine-tune them so that they might do slightly better. I'll talk about what are the problems of fine-tuning later on, but they seem to do pretty badly. And one of the other things I want to tell you is, in general, the original example that I gave you, the anecdotal example, that was an unsolvable problem. And LLMs are actually very bad at unsolvable problems because they think that they should give you some answer. And in fact, anyway, again, this crowd probably knows, but if any time LLM by mistake gives a correct answer to a reasoning problem, ask, are you sure? I heard it's the other way around. It will change its mind because they've been RLHF to death. So that the most important thing is to make you happy, not be correct. Okay. So anyway, in fact, these instances are all actually solvable instances. If they're unsolvable, the numbers would be much worse even in blocks world. Okay. So this is solvable instances. Okay, and so anyway, there are other people, not just me, there are other people who agree with this sort of a thing, and Jan has been like a very big proponent of this, and so he has a big, amplifying effect on make people taking this stuff seriously. Okay, we've been saying this from 2022 onwards. More recently, in the beginning, actually, People would not believe it. I remember Karthik going to FMDM, Foundation Models for Decision Making workshop at New York in 2022. There was this, something like 10 times, 15 times size of this room, because every NeurIPS workshop is huge, and tons of posters, all of which says LLMs actually can plan all sorts of great things, and this one poster saying no, they can't. And it was fun, training for the poor guy. But now, of course, more and more people realize this. So travel planning, it turns out actually it's not even a planning problem, it's a scheduling problem. And this crowd understands the difference between planning and scheduling, I hope. But where essentially, travel planning benchmark, somebody made this from Ohio State, from NLP community. NLP in general has discovered reasoning, because partly nothing else is left in NLP. Because the information extraction and the statistical language processing is solved with LLMs once you wait for the LLM treatment. And so now suddenly the stuff that you used to care about when some of you are old enough, and when I was in graduate school, I took a natural language understanding course by James Allen. James Allen basically hung around in these areas as well as in NLP community. That stuff has become very important, except the grad students unfortunately haven't kept up with the reasoning part of the curriculum for good reasons, presumably, because they were just not being exposed to it. And so to some extent there's a bit of reinventing the wheels going on. But anyway, this group essentially shows that travel planning benchmark that they made, GPT-4 can only solve 0.6% of the problems that they made. That's even worse than the Bloxworld stuff. So it's not just that Bloxworld and IPC are the bad guys. This one is the Google group, which again does essentially scheduling problems, what they call natural plan, which is trip planning, calendar planning, and meeting planning. They're all essentially scheduling problems. And I don't quite know what makes it natural. Presumably their idea is that they're writing this in natural language, but essentially these are scheduling problems, and they keep pointing out that they do extremely badly. And so and that they're trying to improve the performance on these systems. So again, I'm not the only one. Other people have finally come around to it. We were just saying it much before. And so why is this? Why did some people even continue to do so, as well as lots of people really believe that LLMs can actually do planning? And here is an interesting way of thinking about it that I find useful, that generative AI systems generative machine learning systems learn distribution. Style is a distributional property. Correctness and factuality is an instance level property. LLMs basically impress you because they give you the answer in the right style. And if you don't know the answer, it looks in the right style and you're just stuck with that and you have no way of checking whether they're correct or not. And the problem basically is civilizationally, we humans have always thought that style is harder than factuality and content and correctness. Because after all, I keep thinking that, even at the time of Shakespeare, there were people who could write Shakespearean stories. The bard could write it in iambic pentameter. Now, any high school dropout can write stuff in iambic pentameter by just asking ChatGPT to write their chunk in iambic pentameter. The content actually and the factuality becomes important. And we are slower to get to it, because again, this has become a common big thing that everybody cares about right now. It's not just a couple of people in KR planning NeurIPS community. Everybody basically believes that LLMs are actually solving stuff because they are talking like things that the answers are in the right style. And that is something that's very hard for us not to fall for. Here's a little example New York Times had an article last year saying that a bunch of people started writing travel planning books, using essentially DALL-E and public domain pictures, and also probably writing like ChatGPT makes the travel plans. And there's people like Rick Steves, those of you from US, and there may be other people in other places who would actually make a living writing travel planning books. They go through all the interesting little things, etc. And that was like $29.99. These are $19.99, and so people are buying this stuff. And then they're going to Europe or various other places, and they find that everything approximately at the top level looks the same, except on the day they go, it turns out that museum would be closed on that day. Or that museum requires you to make reservations beforehand. And the plans in the book weren't telling them that. And so they came back and returned all the books. So this was like a big enough story that New York Times had this. And so my joke around this is that LLMs will give you a wedding plan. Just don't get married with that plan. Even if you already got married, don't try getting married with this, because it's the logistics that fail completely. At the top level, everything has some structure, and they got that structure, but it's the logistics. I mean, even this conference, all the great things about Magdalena and Marie doing stuff. If Hai is not around, things won't be working, and then suddenly we'll be looking at each other's faces thinking what a great thing KR used to be, because logistics matter, okay? And so that a plan cannot just be some sort of an essay, it needs to be executable. If it's not executable, it's not a plan. And most of the time when it fails, it's because they're actually not executable. They should have, but they don't. The other interesting thing is, maybe there's this problem that everybody talks about hallucination about LLMs. Maybe it's this hallucination, and if you nicely ask them, please don't hallucinate, guys, they might. And they might stop hallucinating. And I'm not making this up. I don't know how many of you know. This is, people actually broke through Apple Intelligence's initial prompt. Okay, and the Apple Intelligence initial prompt essentially says, please don't hallucinate, please predict it, and please stick to factual information. As if you put it in the prompt, LLM say, yeah, so I'm not supposed to hallucinate today. And tomorrow I'm not going to hallucinate. Obviously this is nonsensical, but that's where we are stuck with, essentially, that basically people think that hallucination can be stopped by asking it nicely, okay? That just makes no sense. Hallucination and approximate retrieval are features, they're not bugs, okay? LLMs are n-gram models, and thus they do not index and retrieve. We used to make fun of databases. Databases don't make up stuff. They're not creative. You go to a court of law and you say, Your Honor, I'm a great creative witness, they will put you out of the court of law because they don't want you to make up stuff, okay? When you say that these things are essentially, kind of generated, they're never retrieving, they are essentially completing the prompt at that time based on the statistical probabilities of the conditional probability table, and given that essentially the completion is in the same distribution as in the text that they've been trained. That's the only thing. It looked like the kind of text you would have got. If you actually, the plan was correct, it would have kind of read like this. It's not exactly correct, but it would have read like this. Okay? This is what you think, and you'd understand if you realize that they're essentially n-gram models. And prompt engineering doesn't change this. There's this hope that please don't hallucinate. My boss wouldn't get mad at me if you hallucinate. That sort of stuff doesn't care. LLMs doesn't matter unless you, in fact, essentially somehow change the training data such that it will have a statistical property that if you have these magical incantations, it will have less of, made up facts. That's very unlikely. So whether or not changing the prompt gives the factual completion depends on the prompter knowing enough to tell whether the given answer is an accurate one. And so my big contribution to this discourse has been this particular XKCD thing that I repurposed and said that the impressive reasoning and maybe even factuality abilities of LLMs depend on the prompter knowing the answer. So you know the answer and you're checking whether the LLM knows or not, and you keep changing the prompt until you come up with the correct answer. I don't know how many of you call Google to check whether Larry Page and Sergey Brin know the answers to the questions you already know the answers to. That's not what we search for. Okay, in general, if the search answer should be right, and trustworthy, even if you don't know it. And the prompting information depends very much on humans essentially approximately knowing what the correct answer is. And so people will get very impressed that, if I ask it right away, it seems to be giving the right answer. But you have to do this systematically to show that there is actually no magic. So anyway, since you can kind of tell that I'm spending too much time on LLMs, but I'm not doing enough nice hyping about LLMs. So I made this into a t-shirt also because, I have to make my own money. I'm not getting startup money. So I sell this in the conference keynotes. This was me wearing that at ACL in Bangkok in August. So, you have to make money. And so anyway, so that basically gets me to the first part, basically that LLMs by themselves cannot plan, and they can't do planning in autonomous modes. And at this point, you might be thinking, well, what about chain of thought? And as I said, and people got mad at me, that there is Hinduism, there is Buddhism, there is Christianity, and there is chain of thought. It's a religion to some extent. And that people think that if you somehow give the chain of thought prompt correctly, LLMs will answer the things right, nonsensical. Because as I said, actually, prompts don't change things unless you happen to know the answer. And so we have this paper. Again, I'm not just an old man yelling, I am an old man yelling, but I also am an old man yelling with papers in URIPs. So that kind of makes a difference. So if you want to yell, do that too, and it'll be very useful. I think it actually, you guys know a lot, and it'll be very useful to get all of us into the same place. So we actually presenting this paper on chain of thoughtlessness and analysis of chain of thought in planning at URIPs this year. And that essentially basically shows that if you were to take something block solve problems and sort of give the whole point of chain of thought, the presumption is that the conceit is that you not only give a procedure about how to solve a problem and give an example of that, and example of it solving the problem. So for example, in block solve, those of you from this community know that it turns out you can solve any block solve problem by putting all the blocks on the table first and then putting them in the correct stack. And you will only be within twice the optimal. And this whole thing that I'm saying only makes sense to this crowd. Nobody cares about optimality anymore. Because LLMs, we're just happy that there's actually a solution. But if you do this, first of all, you'll get within twice the optimal cost, right? And so we can give variety of different kinds of prompts, more general versus less general chain of thought prompts. And what we find is that for the examples that the prompts were given with, let's say if I gave them a 3-4 blocks example, it works better for 3-4 blocks problems, but fails for 6, 7, 8, 9, 10, etc. problems. And if you believe that this is something crazy about IPC, here is a last letter concatenation. We are talking about AGI, and in the great reasoning that AGI systems are checked on as these problems like last letter concatenation. That is, if you give K words, you take the last letters of each of these words and make them into a string. That's the problem. Turns out. Okay, and what's interesting is, in fact, chain of thought paper shows that, look, with the chain of thought prompt, it does better. And what we showed is, the problem with LLMs is don't stop when it starts working. Ask more. That's what essentially all empirical science is supposed to be, right? So it turns out that if you do last letter concatenation, you give examples for 2 or 4 or 3 word problems, it improves for 2, 3, 4 word problems, but as you increase the number of words, it dies. Do you know anybody who would like to have presumptions of AGI who can't understand that last letter concatenation? Once you give the procedure, you may only be able to do it for the examples you have shown and not for the longer examples. In general, they are unable to follow procedures. This is a very important thing. That's what we are finding. Now, I think, this crowd knows who this guy is. Most of AI has forgotten. There's this guy called John McCarthy who said the whole point of AI is, holy grail for AI is to make an advice taker system. So advice taking is not supposed to be easy. It's considered to be AI complete. So I always wondered, why is chain of thought supposed to be work? And not surprisingly, it's actually not working. It only works for the examples that you're given. And what John McCarthy had in mind is basically taking general advice of the kind, here is general procedure for blocks word, just answer it for all the problems. So my joke, I spend a bunch of time making jokes on Twitter. And so my joke on chain of thought is, those of you who remember the capitalist thing about give a man a fish and feed him for the day, and teach him how to fish and feed him for life. Well, LLMs don't understand fishing, arbitrary number of fish. So you actually have to say, give LLM a fish and feed for a day, give how to fish 2 fish and feed for 2 days, fish 3 fish and feed for 3 days, fish 4 fish and feed for 4 days. At which point of time, heck with the capitalism, we just basically leave up that. But anyway, the point being is that there's no free lunch. There is really no free lunch at all. Okay. So by the way, this is chain of thought. One of co-authors of chain of thought, Dale Schurman's, giving a talk at ICAPS last year as a keynote speaker, and basically saying, yeah, I was right, that they don't actually do procedures. So I'm not making this up. So fine-tuned LLMs with successful plans, that's the other possibility. If you want to fine-tune, can this improve? Our own results show that LLMs, the fine-tuning, that is actually not a great idea. It improves for, again, the size of the problems for which you have fine-tuned, but it doesn't generalize. Length generalization, object number generalization, the kinds of things that you expect, that you learn from examples, doesn't happen. Okay. In general, there is a bit of a Rube Goldberg nature, I am calling it, to fine-tuning. Okay. Essentially, if you have the go-fi approach for solving a planning problem is get the domain model, get a combinatorial search planner, have the planner solve the problem. But that's old-fashioned. It's the kind of stuff some of the people in this room do. And then the Llama, which is the LLM AI, is get the domain model, get a combinatorial search planner, make a trillion block-solved problems, make the planner solve them all, fine-tune GPT-4 with the problems and the solutions, alternatively index the trillion solutions, the vector database for later RAG, in case you're into RAG, have the fine-tuned RAG GPT-4 guess the solution for the given problem, ensure the correctness of the guess with an external validator simulator working on LLM-Modulo, and if by luck the guess are right, write a newspaper about the effectiveness of synthetic data. And as they say in the Reduce Shakespeare Company, the more you know the original, the funnier this thing gets, because this is actually how fine-tuning is done right now. And we are currently not caring about the costs of fine-tuning and whether or not they're being recouped in the thing. So why? Because complexity, depth of computational complexity. Again, one of the only few conferences where you still talk about computational complexity is this. Most people don't talk about computational complexity, and essentially you assume that you can just spend as much time in the pre-training and somehow you'll fail upwards in case this thing stops and then somebody else will pay for a bigger startup or something. So there is a good question as to whether any of this stuff will work. In general, I think in versus out of distribution has become the thing that machine learning people are too enamored with. And it's out of distribution, it's not just out of distribution, it's out of distribution with a larger number of blocks, larger number of words. That thing matters. And what people tend to do is, we are looking at like 2 or 3 block problems, and then some of the ones that I didn't show, the machine is doing well, so it has generalized. That's the least interesting form of generalization. So in general, I would actually argue that you need to know things like deductive closure, and you're essentially trying to learn the deductive closure from the procedure, and there's no reason that LLMs can compute other parts of the deductive closure just because they've been fine-tuned on small parts of the smaller number of blocks of problems. That's essentially what your last letter concatenation is showing. There's a newer way of doing this, which is also unfortunately bad. Again, called fine-tuning with what derivational traces. Not only are you going to fine-tune with, here is a problem, here is a solution, but here's the problem. Here is what A star search would do in solving this problem. Close list, open list, close list, open list, close list, open list, and then final solution. And then you train in LLM, fine-tune the LLM on this entire data. And then when it is actually answering the problem, it tries to give these steps, intermediate steps, as if it is thinking, and then gives the final answer. Nobody actually checks in these problems whether in fact they did the right kind of reasoning, whether in fact the closed list, open list manipulations they are making will correspond at all to a consistent A star operation. They just take the advantage, they take credit if in fact the accuracy improves. And accuracy can be improving for all sorts of other reasons that have nothing to do with this kind of derivational trace. So the other thing here is self-verification. And the self-verification is something else that people fall for because they think that, well, it's like knowing half computer science. And you know that in computer science that generation is have higher complexity than verification in many, many problems. And so if LLMs can't generate, maybe they can verify. But that would make sense if they're actually reasoning, if they're actually solving the problem as against retrieving the solution. If you're retrieving the solution, the computational complexity arguments don't make any sense. We actually showed that, in fact, not only don't LLMs do any better in the verification, if they self-verify, there are cases where their overall effectiveness in terms of accuracy falls down. That's because if you are verifying, if you don't know what the correct answer is and you are second guessing your own answers, my sense to students is if you don't know what the correct answer is, go with your first instinct rather than trying to critique, because you could actually pass over by the correct answer to stop at the wrong answer, which is exactly what happens in the self-verification. Okay, so why is this all happening? Well, basically planning involves planning knowledge and this sort of combinatorial reasoning part. The classical techniques ignored the knowledge part. They said somebody will write down the domain models. LLMs are actually good at that. They can give you approximate models of the knowledge. But on the other hand, they're really bad at interaction resolution, plan merging, plan modification, etc., etc. I have at least until 10:15, right? Let me take the time because we started actually 5 minutes late. I planned. Okay. So basically, then the reason is that they're actually bad in this reasoning part. And so, in fact, to show this, what we did is we took the blocks world problem, removed all the interactions. How do you remove interactions from blocks world? They don't have any preconditions. They don't have any delete lists. At which point, every sub-goal, sub-plan can be concatenated in any which way with any other sub-goal, sub-plan, and you will be met. Right? It will be unnecessarily boring blocks world. Blocks world is boring itself, and this becomes even more boring. But hey, LLMs do much better in that. Okay, so if you remove interactions, then they do better. So if you actually look at all the claims about when they are doing planning, these are domains where either interactions are not there or people are pushing it under the rug. And this is a point that you have to understand. The reason there's still some red left is because LLMs can't count. This is known. So if you have like 8 goals to support, they may only support 7 and say that's enough. No, let's call it a day. Okay, so can LLMs help planning at all? This all looks kind of sad, but actually it turns out that there's actually a very positive way in which they can be good at supporting. They are amazing idea generators. I don't know how many of you know how Einstein came up with equal to MC squared. He was stuck. He was trying MC cube, MC power 4, MC power 7, and then this janitorial lady came and cleaned the table and said, now it's all squared away. And that's how you got equal to MC squared. The reason that I say this is ideas can come from anywhere. The interesting question is the way the ideas come and the way you check them are two very different things. No mathematician ever says, I got the idea when I was carefully working a problem out. They're always in the toilet or walking around somewhere. But then they don't just submit the paper after that. They just actually go and check whether in fact that idea makes sense. And that part, LLM-Modulo can help with the LLMs by having external verifiers. In general, I would like to make you think of this, that this is go-fi stuff. People would talk to subject matter experts. This knowledge engineer will write them in some sort of a formal way, and then this knowledge base, you will do some, actual standardized reasoning. LLMs made all of that stuff approximate. They can actually give you knowledge about pretty much any domain and any aspect of the reasoning problem, but that's approximate, no guarantees. And so the interesting question would be, if you have this, how would you use this information? So as I say in this very long slide, that the $1 million question for reasoning and planning in the event of LLMs is, how would you do planning if you have some doddering know-it-all uncle ready to give you any kind of knowledge, but no guarantees? We never had such an uncle before. So LLMs are actually such an uncle. And so we should use that, and in fact. And so in some sense, the positive part essentially is they can actually support planning by being a very good generator outside, which will then be checked by the verifiers coming from either symbolic community or LLMs themselves as style checkers. So LLM-Modulo framework, LLMs can play multiple roles, guess plans, guess domain models, help elaborate the problem specification, translate formats, pretty much all of these things they can wind up doing. There's a spotlight position paper that I presented at ICML this year that already has like some 100 citations. That basically talks about this way of doing LLMs, LLM-Modulo. So the basic idea is you have this large language model and there's this bank of critiques. And the critiques can be correctness critiques. Those are essentially LLMs can't do that. They have to have some formal verifiers. The models driving those formal verifiers may well be learned from LLMs, can be teased out from LLMs. I'll show you an example of it. And they can also be style critics. And if they're style critics, there's no other game in town. With all due respect to this community as well as the community I come from, we always had very baroque approaches for checking style. There is this idea called hierarchical task network planning in planning. That is like we know how to make correct plans, but we don't know how to make plans that people will like. And so they will try to get that by essentially having hierarchical task networks. Instead, actually, LLMs give stuff that people will like, they just don't work. many a time. And so the style path they can check. So if you take just a single critique case in the blocks world and the Newrips paper, we show that with 15 iterations, the blocks world accuracy, which used to be about 30%, goes up to 82%. With just 15 iterations, the verifier saying, just guess again, here is something wrong with you. And this here is something wrong with your plan is the back prompt. This is automatically generated back prompt. There's no human intervention at all. Okay, and then the bank of critiques essentially, the other thing that I want to tell this community is there is a temptation to, instead of having critiques, have solvers. Solvers are not composable. Because if you have, let's say, classical planning, and suddenly have temporal constraints, you need to get a temporal planner. Whereas verifiers are composable. You have a classical planner, you have time, you start throwing in a time verifier. You start throwing in resource verifier. And each of them independently give these badges. And then if everybody gives the badge, then the plan goes through, right? And then style ones give you, okay, you're looking good, sort of a brand thing. So I actually think that it's very important. Can you give me the next slide? Excuse me. Yeah, so I would prefer verifiers to solvers because of this very good property. And in fact, you can throw in extra verifiers as needed. Soundness and completeness, I don't need to tell this crowd. Soundness is guaranteed because the verifiers are sound. And the correctness verifiers. And completeness is not guaranteed, but it depends on how good LLMs are in generating all possible candidates. And if those of you who know anything like tree of thoughts kinds of work, essentially they should be seen as diversifying the prompts such that LLM is forced to give diverse candidates rather than just the candidates that it winds up giving. There are different kinds of critiques. I already mentioned correctness as a style. Critiques can be binary. They can also be give constructive by saying, here are all the things that are wrong with the plan, and here is, by the way, here is a couple of steps that you can put in the plan so that will be correct. And the constructive critics might be actually solving the problem in a relaxed way, in some sort of like relaxed planning graph, for example. And this meta controller can combine the criticisms that are coming, and in fact, by just ordering the criticisms that it wants to deal with, let's say if you have 1 to 10 critiques, and it looks at the first 3 critiques first, and then the first 6, and then the first 9, that's hierarchical reasoning in a generate and test framework. So you could do it that way. Just to give you an idea that they're actually very good at the style part, even though they're not good at the verification part. This is a COMB paper. This is a Conference on Language Modeling paper where we essentially use VLMs to look at the robot behavior, continuous behavior of robots, and showing that in fact LLMs are reasonable in actually giving criticisms of what is wrong about them, not from the correctness point of view, but from the point of view of what humans will like. For example, one of the criticisms would be, don't give, if you show a behavior where you're giving a pair of scissors with the pointy end towards the human, they will say don't do that. And this was not input, it was just learned from the massive training that they have. So they are actually pretty good style vibe generated that thing. So that's for the thing. And then I would skip over this. It turns out that you can also capture some of the they can use LLMs as sort of the explicability critiques and interpretability critiques, and we have an HRI paper showing it. It's not foolproof, but it is better than giving something and after having the human say this is not good. Okay, so that's something that they can do too. And then, in fact, LLM-Modulo improves performance with guarantees on multiple benchmarks. It turns out it does it on the travel planning benchmarks, the trip planning, meeting planning, and also the calendar scheduling. And so the second column is with the LLM-Modulo and with same number of iterations, 25 iterations max. Okay? And so it actually improves their performance. I'm going to skip over this. Those slides are there that they actually can improve performance in these benchmarks that we didn't generate. It's other people generated it. Okay. Can I get the next slide? Okay. You can also use the same thing to, as I mentioned, to generate the model that runs the LLM, the verifier. So if you have actually a PDL verifier which needs a PDL model, you can learn the PDL model from the LLM. You can tease one from the LLM model by saying what are the actions, what are the preconditions, etc. It's not going to be guaranteed, but it reduces the amount of work. So there's a Newrips 23 paper that shows how you can use LLMs to get the domain models. So that was like completing the thing. Okay, that's a summary of the LLM-Modulo. I actually think that this unifies all the same uses of LLMs in reasoning problems. There's an argument saying that actually things like alpha geometry as well as program synthesis community, what they're doing, can be seen as LLM-Modulo. You can read that. And then I want to say this, that this is actually a question of why are we solving these problems with LLMs when you have other approaches? Well, the idea is, I mean, I'm old enough to know this paper. I don't know how many of you know this paper. This is by John Doyle and John Doyle and Ramesh Patil about two pieces of knowledge representation. That's a great argument that don't just basically allow humans to say whatever the specification is and provide the guarantees that you can. And LLMs actually allow you to do that for planning. So that's part of the reason I use it. And I'm going to just take a couple more minutes, and because strawberry is important. Okay, so about strawberry. About O1, as I said, Noam Brown, when the strawberry was released, essentially as in his pre-thread, Rao said the following problem can't be solved, and O1 solves it. So that was like my first time when I actually was responsible for extra $1 trillion being spent on pre-training, apparently, because I said this don't, and then actually one of the things they show is it actually does improve performance. So the question, of course, as I said, is this becomes a stone soup part. So LLMs by themselves, the autoregressive LLMs by themselves can't reason, but if you put reasoning on top, they can reason. The question then is, do you want to do that? Okay. So one of the things, next slide. So there are two papers that you might be interested in, they're very recent papers. But the important thing to remember is the way to understand O1, it's not an autoregressive LLM at all. Don't let anybody tell you that they are. The problem, of course, is O1 is not public. They don't tell you what they're actually doing because they said it's closed AI right now. But given enough of the information there, you can actually make sense of what is happening in terms of extending a mu0 like reinforcement learning framework on top of LLMs. And the idea there is the state becomes a language prompt. Action becomes an extra prompt that you are adding to the language prompt so that certain kinds of outputs are coming out of the LLM. LLM itself is the environment. And the learning is basically done both in the pre-training phase to learn the Q values. So you can think of this as a separate small LLM might actually be learning how to generate these COTs. And then it is further improved in a MCT style thing in the actual reasoning time, inference time. And this is what actually makes it very, very clearly not an LLM, because you don't know what they do in the pre-training, but every LLM before O1, the moment you hit return, it gives the answer. It starts spitting out the answer. Okay. This one takes extra time because it's actually trying to do MCT style reasoning, and they charge you money for that. And so if you're interested in that part, you can look at that. So this is our results, that O1 is indeed better than autoregressive LLMs, but at quite considerable API access cost. It too falls down, it starts falling down in accuracy for the larger problems than LLMs do. But on the other hand, look at the amounts of money. Basically, last month, our group spent $6,000 for API access cost. Okay, so as I say, as Jack Nicholson would say, you can't have reasoning because you can't afford reasoning, because the inference costs are so high that even checking whether Bloxwell problems can be solved, we spend $6,000. So God knows anybody who wants to run this overnight or something of that kind. Okay. Now, remember I said LLM-Modulo? You can think of these as LRMs, which have a better accuracy profile by actually compiling more, basically becoming more like reasoning systems with the pseudo COT moves. So we consider LRM modulo, where we just, instead of LLM, we put O1 in the middle, and it turns out you can improve the performance, the accuracy of O1 in the same LLM modulo fashion. But now when we improve, we have guarantees. Even O1 doesn't give any guarantees that its solutions are correct. There are many times it has false solutions and so on. So we, on the other hand, can guarantee that stuff. And in fact, LLM-Modulo can even be a cheaper alternatives to using O1. You can use an autoregressive model in LLM-Modulo fashion and be cheaper than using O1. This is good old-fashioned computer science where you actually care about costs and that would might make sense. So this all brings me to this point that LLMs can't plan, and LLMs themselves can't plan and reason, but if you put them in a generative strategy such as LLM-Modulo, or graft an RL component in both training and inference phases like Strawberry, then they can. But the question then is, who gets the credit? Is it the generate test verifier who is getting the credit? Is it the RL part which is doing the inference that's getting the credit? Or is it the autoregressive LLM that you think that is getting credit? So that's the final slide, and there is a longer version of this in the ICML 2024 tutorial, although the O1 part came much more recent. This is like the cutting edge, most recent stuff. And then if you like general points about this sort of LLM stuff, I have a long chat, machine learning street stuff that's for some reason become viral. Like 67,000 people apparently watched it. I don't know what 67,000 people look like, but apparently they watched this. So you might look at that, and I'm going to stop, and thank you again for your